So in this lesson, we'll cover relative efficiency related to Latin square designs, and then we'll talk about some advantages and disadvantages and an extension of the Latin square design. So we've talked about relative efficiency before when we were comparing the RCBD back to the CRD. And again, recall that the relative efficiency provides us with an idea of whether the blocking factors were effective or efficient, which could be useful in helping us set up future studies. Additionally, recall that the relative efficiency is not a formal statistical test. So with the Latin square, we're able to compare it with three things. We can compare it with the randomized complete block design when we ignore the row, or when we ignore the columns, or we can ignore both the row and column blocks and just compare it to a CRD. So the three relative efficiencies, this is just some notation right here that we compare to. And what this notation says is the relative efficiency, the Latin square, compared to the one with no row, the RCBD with no column, and then the CRD. The definitions for the relative efficiency compared to the respective are here. Recall that the MSR, these MSE, are all from the ANOVA table for the Latin square. Okay, and this comes back to the idea that we ran a Latin square, our experiment was a Latin square, and we're trying to compare it to these other three experiments that we didn't run. Our rule of thumb is that our block was effective or efficient if the relative efficiency is greater than 1.25. Again, this is not a formal statistical test. This is just trying to develop some intuition for us of whether a future study should or shouldn't have the blocks. So if we go back to our spreadsheet example, a law firm was trying to determine if these four spreadsheets, A, B, C, and D, which one's the easiest to use for their secretaries. We ended up developing or getting an ANOVA table that looked like this. And so we want to compare the relative efficiency. But before we do that, we could also just simply look at the ANOVA table to develop some intuition. So let's say we consider the MSR, or the row, which is equivalent to 0.067. Now, if we didn't block by the row or task, then our sums of squared would have come down into the error. Our degree of freedom would have also come down into the error. Okay. When we account for the block, so if we didn't have the block, our sums of squared and our degree of freedom would have come into our error. Now, when we block, or when blocking is most effective, is when we pull out our sums of squares error. Is it enough to compensate for our loss of degrees of freedom? We talked about this when we talked about relative efficiency back in lesson 3 with RCBDs. So I don't believe that by taking out 0.2 from our sums of squares would be enough to compensate for the fact that we lost 3 degrees of freedom. And so that's the intuition, but relative efficiency is going to help us to determine this. And so our first example is comparing the Latin squared to the RCBD with no tasks, or not the row column or the row block. We ended up just taking these values. MSR comes again from the Latin square ANOVA table, MSE is coming from the Latin square ANOVA table, and our T is 4. We get a relative efficiency of 0.917, and so this is kind of telling us that we didn't really gain much from blocking by task. Again, this is a warning. This doesn't mean we now go back, we rerun our analysis using no block for task, because if we design our experiment using a Latin square design, then we run it as a Latin square design. What this is going to tell us is that maybe in the future, if we did another analysis, maybe we don't want to block by task. We could also do the relative efficiency for no column block, where we get our RE to be 1.18. Now, this is kind of borderline to our rule of thumb. We did gain a little bit more from blocking out secretary to secretary variability, although it doesn't appear to be a lot. We can also compare it to our CRD, which is pretty close to 1. So blocking for both secretary and task wasn't useful. And maybe next time, if you were run to this experiment again, maybe a completely randomized design would be beneficial. And so we have our conclusions with that maybe blocking by secretary, task, or both wasn't effective since all the REs were less than 1.25. Now, the advantage of a Latin square is that it's a simple analysis and we're able to save our resources, which is always a positive if we're limited on resources. The disadvantage is it's not the most flexible design in that we require our number of blocks for row and column to be equal to our number of treatments. And so in our spreadsheet case, if maybe we had 5 secretaries, we would also need 5 columns and we would also need 5 spreadsheets. So we would need another spreadsheet E. So it's not the most flexible in that case. It also assumes additivity. We're assuming additivity because we don't have replication. And so we assume that the treatment effects are the same across the row and the column. Latin squares are typically useful or best when T is between 5 and 10. If T is too small, our errors of degree of freedom will be too big, and so our relative efficiencies are small. Or if T is too big, so think about if we had 20 blocks of row, 20 blocks for the columns, and then 20 treatments, that assumption of additivity starts to become a little bit questionable, that you're assuming the treatment effect are the exact same across the row and columns. So those are just some advantages and disadvantages. You can also extend the Latin square to be a repeated Latin square. And so you're going to create replications now, and this will address the non-additivity, or allow us to have non-additivity. So it's addressing the issue of additivity that we just talked about. And so how it would look is we have one replication that would look like this. This follows a Latin square because A, B, C, D are here, and A, B, C, D are here. Following that, one treatment is per row and column. Then we could have a replication where, again, we're following the Latin square criterion, but these aren't the exact same. So it's getting us that replication. This concludes our notes for the Latin square. Now we're going to move on to lesson 6, which we'll be talking about unbalanced designs. I hope you guys all have a great day, and I'll see you in your next lesson.